Oh, hi, Dr. Joe.
Hi, good morning. I was muted.
Okay, we can wait a couple more minutes.
Yeah, I think
Okay.
anyways we are early right now.
Right, yeah.
Yeah.
Should we start, Anu?
Yeah, Chinchi, go ahead. I think we should.
Okay. Hello, everyone. This is Jingji Wang. I'm the developer of this CLAMP NLP software. And today I'm going to show the basic functionality of this CLAMP tool. And you can stop me anytime if you have questions or if you want to learn more details about some of these functionalities. So CLAMP is available as a zip package. You can go to the CLAMP website, clamp.uth.edu, download CLAMP, and then unzip, double click to run. We have different versions. The GUI version, which is this one, that's a tool to develop all the NLP pipelines. And we have another package called CLAMP command line version. The command line version is designed to execute all the pipelines. So this is development tool. That one is for running pipeline on a large data set, the command line version. So this is the CLAMP package. And if you double click, it will give you the primary interface like this. In the center, that's the editor area. That's the area where you work with the clinical documents. And on the left side, I have the NLP resource components. Basically, we have the machine learning components. That's for name entity recognition feature extraction, and also for the natural language processing components. One component, actually, that's one kind of NLP functions. For example, the assertion classifier. This one is a component, and the function is to detect the negation mentions from the note. So sometimes the patient says, the note says the patient denies something. That something is a clinical problem, but it's denied. So that's a negation modifier. And we will use this component to detect the negations. And also we see a lot of these others like the sentence detection. That's the most fundamental one, which will break the notes into sentences. And also tokenizer. This will break the sentence into tokens. You may notice that for one component, actually there are different processors. One processor is one specific algorithm. For example, for tokenization, there may be different strategy how to split the tokens. Could be rule-based one, could be the machine learning-based one, or just simply tokenize the input by the white space. This is useful when sometimes their input document is already tokenized by other tools. You can just tell CLAMP, don't do tokenization, just simply tokenize by space. And also have other components. The critical one, the name entity recognition. We have the machine learning based name entity recognition. This one will recognize all these clinical information like problems, treatment, and tests from the notes. Here's one example output. And then to run these NLP components, we need to create a project. Go to the icon here, new project, and there are two options. One is for corpus annotation. This one is useful when you annotate your own corpus. We will cover that later. And then we have the NLP pipeline here. You can type a name. And select NLP pipeline. Say finish. And then in the pipeline view here, you will see the new project you created. It has two folders, one component folder. This is a place where you put all these NLP components and also a data. This one for the data input and output. And under the components, we have the pipeline file. Double click on this one. It gives you the empty pipeline because we haven't put anything in here yet. So then with this pipeline, we can drag and drop from the left side, the NLP components, drag and drop into the pipeline file. So if we want to use the machine learning based NER, then we drag and drop from here to the pipeline. But here you may see one error because these NLP components, they have dependencies with each other. For example, you drag and drop the CRF NER, it tells you to run this component, you need to drag and drop more like post tagging, sentence detection, and section of the thing. You can keep drag and dropping based on the message here, or I designed this autofix. So try this autofix button. I will try to resolve all the dependency issues, basically add all the missing components and then put them in the right order. So we can drag and drop more into this pipeline. And the different combinations of these components can achieve different functionalities. And this is how to build the basic pipeline. And then after the pipeline is ready, next step is try to put some data into this data folder. You can copy the clinical notes from CLAMP or outside of CLAMP from the system. I have some demo notes here. That's a de-identified empty sample nodes. So copy on them, and then right click, paste on this input folder. So the input format is just a regular text file, the .txt file. It's just a discharge summary with all these sections. And then pipeline's ready, data is ready. Next step, go to this run pipeline icon, and then start to run this pipeline. You may see some output information at the console. So initially, Clamp will load all the NLP resource into memory. This one may take maybe 10 or 20 seconds, depending on how many components are there in the pipeline. And then Clamp will process the input file one by one. So after running the pipeline, you got the output here. And in the Clamp GUI, we have two formats of the output. One is the TXT file. If we double click, we'll show you the content here. Basically, that's the type delimited format. So it has several columns. The first column is the character offset of that concept. Say start from this offset to this offset. That's a clinical concept. And the semantic type is test. And then we have a UMLS concept ID, the UMLS CUI, which is now, because if you remember the pipeline, we haven't put any concept mapping in this pipeline yet. So this column is now. And then we have the assertion information. Basically, it says the concept is present or just absent. Don't have this concept, it's negated. And then in the last column, we have the concept itself. So this QE column is now. Suppose we want some output at this concept ID level, then in that case, we go back to the NLP components and then find the concept mapping, drag and drop from dictionary-based UMLS encoder into this pipeline. So the first time you use the UMLS encoder, it will ask you for the UMLS account ID. This is the validation, make sure that you have the access to the Unified Medical Language System. You can get that account ID at the UMLS website, and then input username, password here, we'll validate, and then if everything is okay, we can run the the UMLS and concept mapping here. So drag and drop one more and then run this pipeline again. Still, it will do the initialization. And by the way, during the pipeline running, you have a chance to cancel pipeline here. In the progress bar, hit this red icon here. You can stop a pipeline anytime you like. So this time, if you open the text file again, you see now we have the UMLS concept ID. That's the output of this component. So the text format is designed to copy the NLP output to Excel or just import everything to database. And also we have this XML format. In this one, you can double click. And this one is for visualization. If you open XML in Clamp, I will highlight all these clinical concepts recognized from the NLP output. So in here, all the concept, and then if you stop here, it will give you the attribute. Say the assertion information on this entity, the concept ID, and the official term of this concept ID. On the right side, you have the display option. Sometimes the color is difficult to review. You can change the color. Double click here. Change to a different color. And also for display option, you can see you have a chance to hide all the entities. Sometimes there are missing information in the NLP output, then you can say disable them all and just focus on one type of these entities. That's for the display. But everything is still in this XML file. And another thing I need to mention is about the lower level information. So about the section detection result, you can see enable the section. It will tell you from the beginning to here, that's actually a section, clinical section. And from here all the way down, that's another section called description section. And also check the sentence level, sentence detection result, and then even at the token level. So that's basically how to build a pipeline from scratch and the input-output data format. So far, any questions? You can type a question if you like it, the chat box, I can see that.
So Jinchi, there's a
Yeah.
question. They're asking what is the input format? So I think they called in maybe a little late. What is the input format for the program and how flexible is it?
Input format for the CLAMP software, yeah. Like I showed for the GUI, we take the text file as input, the .txt, all these just a text. But if you are familiar with the programming, then we have the programming API. Basically, you write the input wrapper, then we can take any kind of input format, like read from the database, read from XML, read from JSON. All these things are possible with programming API. And yeah, even for the PDF file, if it's text-based PDF, you can write a wrapper, extract all the text field, and then feed to the pipeline using program API. But for the GUI, of course, it only takes the text file.
Does that answer the question?
I didn't see question. Really, did you get that question, Anu?
I think it was sent like a private chat message.
Oh, private message. Okay.
Yeah.
Good. Cool. Okay, I can continue.
Yeah. Go ahead, Jinchi.
Right. So I showed how to build pipeline using the NLP resource from scratch, but actually in the CLAMP development, we do have some of these. Did I see something?
Yeah.
Right. Okay.
Question.
Yeah.
Can you?
Yeah, I'm going to. Hi, Heidi. I'm going to show the pipeline library here. So yeah. So we do provide this pipeline library. That's like a collection of these common clinical natural language tasks. Like in the behavioral category, we have a smoking status detection. And for the disease-specific things, we have a bleeding extraction, basically extract all the bleeding concept and then map to the bleeding concept ID. Then colorectal cancer, and we have another, this one is pathology nodes processing pipeline, basically extract all the cancer stage, biomarker, procedure, all these cancer pathology related information. And in the general pipeline, I show the most fundamental components here, but actually we have much more. I will show this clinical NER attribute, but in the pipeline library, we have a de-identification pipeline, the disease-specific, medication-specific, and lab test-specific pipeline. So the CLAMP NER attribute pipeline, actually, this is the most comprehensive one. We can, if you want to use a pipeline library, this one is read only. To use it, you have to drag and drop from the library to my pipeline. And then CLAMP will create the pipeline project here. So it will extract everything and then make the pipeline project here. It's similar like the pipeline we built from scratch, right? All these folders also have a component, but this time it's not empty. I have lots of these pre-existing components into this pipeline. So it's about, it has I think more than 20 of these components. So from the sentence detection, tokenization, all the way to concept recognition, negation detection, and concept mapping, temporal, and even modifiers. Modifiers means for a clinical problem, we need to find modifiers like a condition, like the severity of this problem, like the body location of that problem, and that's all covered by this modifier components. And also we have the medication components, the drug attribute connect. Oh, this one means for the medication, we will connect all these signature informations like the dosage, the frequency, duration. And for lab tests, we connect the lab test name with its associated values. And this one for the ARC-SNOM encoding, specially optimized by for the medications. Generally, if you want to test a clamp system, the easiest way is run this one and this one to see how the default everything works, if that works well on your own data set. Similarly, we can copy paste some notes into this input folder. Let me find something. Data. Still, these are text file. And copy paste to this input folder. Then everything is ready. Pipeline ready, data is ready. Then click this icon to run this pipeline. Yeah, I will not click here because we have 20 of these. Maybe load the pipeline may take more than half a minute. 30 seconds or something. So I've already pre-run this OMP attribute pipeline. I can show the result directly. So after you click the run pipeline, you may get an output like this. So you see all these core concepts are recognized, and also the modifier concept are recognized. And then there's a connection between them if they are actually related. The test and values and the negation to this problem, test of values. So I think this in our attribute pipeline, that's a good starting point. Right.
If
Go
you
ahead.
come up a little bit higher, scroll so that the top of that results file.
Yeah.
Okay, stop right there. Yep, go down a little bit where it says heart. There's like heart and lung.
Yeah.
Let's see.
This one?
Let's see. No, it was actually on the left-hand side. It was a section.
Oh. Let's see section information.
So my question was, it seemed, okay, stop right there, right here. So row 11. So you picked up test and you have rate, but you didn't pick up what was tested, like that heart was what was tested. And with the lungs, you have the test, but you don't have that what was tested. Whereas on 13, you've identified that abdomen, and then, you know, kind of an issue or a problem.
Yeah. Yeah.
So if you needed to go back and try to get it to pick up that this was a heart test and that this was the outcome, or this was a lung test and the outcome, how would you change that?
Yeah, okay, that's actually a very good question. So like I showed in the pipeline, in the existing pipeline, we have the problem modifier recognized. So this one will try to find the modifier only for the problem concept. So the default model doesn't try anything like to connect a modifier to the test concept. But what we can do is that two things we can do. One, we can retrain the model, generate, annotate some corpus, annotate this one as body location and connect with the test and then update the model. The other thing we can do is that we can write some kind of rule-based post-processing. Say if you see a body location at the beginning of one sentence, and then all the text actually belongs to this body location. We can do something like that.
Okay, would you consider this row 11? Would you consider that a section? Could you identify it as a section, or would that
This
not
one
be
is a section. So I think that's related with the granularity of this section definition. In the clamp, we will try to recognize this one as a section.
Mm-hmm.
So all these detailed like item hiders. So this one will think that's a section header. But yeah, you're right. We can I think we can write some kind of rule to recognize all the patterns here. So if you take a look, all these item hiders, that's uppercase, and then followed by a column here.
And all the information identified to the right pertains to that header.
Yes, exactly. Yeah.
So you'd want some linkage.
Yeah, yeah. So for this specific document, if if your input data set had this pattern in common, then we can easily write some rules.
Mm-hmm.
So let me show a little bit how to write these rules. If we go back to the pipeline, and let's add one more thing. So go to the NLP component, the rule engine, drag and drop one more component to the pipeline. So in the rule engine, we can write something like for a token. I mean, there are different ways to run this.
So you just drag this into the NLP, the clamp NER attribute pipeline. Can you drag it into the? This was the one that you got out of the pipeline library, right?
Yes.
Okay, so once you get it out of the pipeline library, it's no longer read-only?
Right. Okay. Yeah. So if you think about it, this one is really like a zipped package.
Mm-hmm.
And after drag and drop, you unzip it into the.
You can modify it. Okay.
Yes. And then for this one, you can do whatever you want. So in this pipeline, you can add, drag and drop more, or even delete some of these components if it's necessary. If it's unnecessary, you can delete all the tempo, for example, right? Yeah, so I'm going to write a very simple rule here, especially for this case. Vital signs. So this rule is designed as a post-processing after the machine learning. It's useful when there are some common patterns after machine learning, and by rules, you can easily fix it. So we can write something like, if we see this two words, vital signs, and then we create another concept on it. And then the semantic tag. It's a bit tricky to write the router rules, but we provide a lot of these examples in the pipeline library, in the smoking something. So you can learn these rules from the examples. So here I create a very simple rule. If we see vital signs, and then these two tokens match the pattern here, create a run this action, the action is create a name entity from the first token to the second token, and the semantic information, we call it atom header. So I think this one we'll try to run it. Let me take a little bit. So you get the idea, right? In the condition part, in this rule, I'm running very specific for vital signs. Actually, if you change the rule here, say if we have a uppercase token followed by a column, then create the item header on all these uppercase words. Let me see if I can see the output. It's still running.
I get the idea. Thank you.
Right. Yeah. Okay. So it's the idea. The clamp tool is really a developing tool, right? You can build all the customization. You can use a pre-existing one and change everything under pre-existing components, write rules, build a machine learning model. I think I'm going to stop it. Okay. So let's go back to this pipeline. Actually, all these components are customizable. So by customizable, I mean if you double click on one of these components, for example, section. Let's use this section as an example. If you double click on the section component, and then you enter the configuration of the section header identification. So in this section, we have one parameter here, the section map. If you look at the section map, actually that's a predefined list of the possible section names and the normalized value. So here, like if you find something in the notes called systems review, then that probably is a section header, and then the normalized name of this section is review the systems. So after running the default settings, probably the clamp will miss some possible section headers from your own data set. In that case, you just go to this section map and add something new into this one, into this file. So sometimes maybe I just add an immunization and call the immunization section. And maybe add something. That's really a data-driven approach. You can change this one based on your input data set. Maybe add something more if necessary. And then even for the machine learning component, I'm collecting on the self-based name entity. If you double click, you see the input is a machine learning model file. So this is the default model file provided by Clamp. It's basically trained based on our own annotations, our own UT nodes and other available clinical nodes. The annotation is trying to recognize, like I said, problem treatment test. But sometimes if you need to recognize more things in addition to clinical to the problem treatment test, you can start to create your own data set and then train this machine learning model. Replace this one with your own model. For example, you want to maybe recognize the gene name, cancer name, the biomarkers, all the other concept type that is not covered by Clamp. In that way, you have to create your own machine learning model. That's a place when you go to this corpus annotation project. So In the corpus annotation, you can annotate corpus and then train the machine learning model. So I can show this part, but before that, still, any question about the pipeline? Any more question about pipeline? Okay.
I think somebody's trying to talk, but maybe they're muted.
I didn't hear anything.
No, but I mean, in the audio, it shows you that somebody was trying to talk, but maybe not.
Right. If you have difficulty with the audio, you can tap into the chat box. I can see the message here. Okay. Yeah. So now we will talk about the corpus annotation and the machine learning model building. So also for the corpus project, go to new project. This time choose corpus annotation and then type a name. Then you may see the corpus project. It's located at the corpus view. So the folder structure is different compared to the pipelines. In the corpus annotation project, we have a folder for all the actually nodes, the clinical nodes. And we have a folder for all the machine learning models you're going to build, and then have this type definition XML. This one is important in the corpus annotation part. If you double click, you see this is how to define the types. So for the annotation, the first thing is to define what kind of entity you want to annotate. Like I said, you can define any entity type of interest to you. Just right click on this entities and then add a new one. Maybe we add a gene name and then add something more like a cancer name. And then keep adding all the entity of interest. And in addition, you can even define a subtype of these entities. So the entities is like a hierarchy structure. You can define a subtype, like type of lung cancers or other cancer types. So that's how to define the entities. And also we can define relationships as well. So right click, add a new relation type. It's a little bit different from the entities. In relationships, you have to define a name, related base, and then you have to define from which kind of entity to which kind of entity can this relation exist. So for example, from the gene name to any of these cancer names, there could be a relation, and the relation name is related base. So this is the interface to define relationships. And after this definition, next thing still, you can copy paste some nodes into the training folder. Let me do that. So just copy one node to the training folder. So this one is still a regular text file, clinical nodes. Double click on this one. You see Clam will try to run some pre-processing and then convert that text file into the XMI, based on which we can do all the annotations. And by converting this XMI, actually we run the pre-processing like split sentence, split tokens, all these pre-processing operations. And once we have this one, you can start to annotate. Just double click, no, select something, and then assign a semantic tag. I just randomly select something. It's not necessarily gene name. And then select something else. So keep annotating until you finish this document. For relationships, you can drag and drop. Drag from this gene name to this cancer name, and then connect them. Say, Did I show any relations? Yeah. So that's how to annotate the relationships. And you can keep annotating until maybe you have hundreds of these nodes, and then start to build a machine learning model. And we all know that human annotation is kind of time consuming, right? You have to manually review all of these. It's kind of cool if you can do the pre-annotation. I mean, before the medical expert let the machine learning do some work and then review the machine learning results or diction lookup results. So in CLAMP tool, we can also do that too. And you may remember when we copy paste some notes, we copy it from the text format. But actually, see, we can deal with the XML, right? Then that means we can copy some output from the pipeline. Like, let me copy something. You can copy the XML file from the pipeline output and then double click. Right, now it's not from scratch anymore, right? You annotate based on the pipeline output. So in the pipeline output XML file, you can see review the output and delete if it's wrong prediction, or even add something more, or change it to another type. So in this way, you can, in a general workflow, what you can do is try to develop this pipeline, and then copy all these output to the Corpus project as a pre-annotation, and then review all these machine learning output, the pipeline output, refine all the annotations. After that, you have a final corpus annotation here. So once you have this corpus annotation, once your corpus is ready, the next step is go to the machine learning training part, say select the training folder, and then train the model. So this is the dialog of how to train the machine learning model in CLAMP. In the dialog, we can set the model name, the location of the training corpus, and then here the feature engineering part. So in CLAMP, we are using the CRF algorithm, the conditional random field, as the machine learning tool for name recognition. And for the feature side, we have these pre-existing features, predefined features. So these features, you can select them all. It's proved to be effective on the clinical notes. So for the CLAMP team, we participate in lots of these NLP challenges, the NLP tasks, where they provide the standard corpus, and every participant will work on the same corpus and then rank based on final performance. So we always rank number 1, number 2 in these challenges. So all these features are proved to be effective in these shared NLP tasks. Generally, you can select them all, then get a reasonable performance on the clinical notes. But sometimes if you're familiar with your data, familiar with the machine learning CRF, then you may try to test with different combinations of these features and then customize this feature. For example, the diction lookup feature, actually, you can provide your own dictionary instead of using the default one provided by CLAMP. And also, if you're familiar with the deep learning, you can train the word embedding and then replace the default word embedding from the CLAMP software with your own one. It may fit your data better, right? That's a feature engineering part. And I have an option for it's like the CRF layer parameters. I disable it, but maybe in the future I will make some drop-down list to optimize the parameter here. That's the default parameter we are using right now. And then this one is for evaluation. Basically, after training the model, you want to know the accuracy of your model, how good the model is, right? There are two ways for the evaluation. One is run with an individual test set. And another one is you can run the cross-validation. So basically, it's like split the training data into several pieces, save one as a test set, and then train the model on the remainings. And then repeat that several times. So it's like validate the performance on the training data itself. Either way is fine, or you can use both of them. So after this one, click finish. The Clamp will start to train the machine learning model. The model training is kind of time consuming too. It depending on the running speed, really depending on your hardware, and also related with the size of your input corpus. Sorry about that. If your input data only contains maybe 100 nodes, it will be very fast. If you have 1,000 nodes, then it's a different story, right? And it's also related with how many features you are using here. Use one feature is fast, use all of them is slow. That's all related with the training time. So I will not click the finish, but I have some pre-trained model. After the model training, you will have an output under this machine learning model folder. So open one, that's the output, some of the output files. The model chart file, that's actually machine learning model you generate from the training set. You can copy this one and then run this one, place this one to the CR, to the pipeline file. And then in the configuration, so previously it's using, oh, I already changed that. So in the configuration, you can switch the model files. Use default model or different model generated from the Corpus project. And then in the output, we have something else. We have a log file. If you double click, you see it contains every detailed information about the training process, the iteration, the CRF toolkit, and to the end of this log file, that's an evaluation result. So I think in this model, I'm just use one feature. So the performance is 70 something. If we use all the features provided, this performance may be higher, 80 something or nearly 90, the F score. And also have precision record for diagnosis or to see more details of the machine learning performance. And the feature file, so if you're familiar with the CRF algorithm or the sequential labeling algorithm, you may understand this feature file better. So the first column, that's the label of one token, the beginning, inside, or outside of an entity, and the remaining is actually that's the features. So in feature one, we say the original word is this one. And the part of speech of that word, basically, is that a verb, is that a noun? And some normalization form of this word is the word after stemming, and the word shape, something. All these detailed features are listed in this feature file. So we are only using one type of feature, the word shape feature. So this file, this line is not too long. If you select them all, you may get maybe more than 100 of these columns as features. And we also have an output folder. In the output folder, if you click, you see actually I'm showing the original the original annotation from domain expert together with the machine learning output. You see this one, that's annotated by the expert as a problem, and then the machine learning predict this one as a problem. If these two are totally overlap, that means a true positive. The machine made a good prediction. But sometimes You see here? The human expert didn't annotate this one, right? But the machine predict this one as a treatment. So that's a false positive. If you see a pattern like this, you may go back to the feature engineering part to change customize the machine learning features to optimize performance. But usually, you see the machine actually make a good prediction, and the human annotator, they forgot that, they missed that. In that case, based on the error analysis, you can go back to the corpus annotation, to the annotation file, and then update the annotation. Then the whole workflow is like refine the training corpus, refine the machine learning features until you get a reasonable output. Yeah, that's a workflow of corpus annotation and the machine learning model development. So like I said, once you have this model, you can run this model within the clinical pipeline. Feed that to the name entity recognition, the CRF name entity recognition. So once everything is finalized, model is okay, pipeline is okay, the next step, that's the end of the NLP development, right? The next step will be export all the NLP resources as a standalone jar file. So with this jar file, you can copy this jar file to the Linux server or some big machine, and then launch this jar file with the command line version, and then process on a large data set. You may process all like the Mimics-3 data set, or process all the PubMed articles. You can do things like that. So this UI tool, the function is develop the pipeline and the machine learning model. And the command line version, after development, export as a jar file, command line version is used to run on a really large data set. In command line version, we have the option for multi-thread, or run either UEMA AS, or run with multi-process, or connect to database. All these execution level functionalities in the command line version. So yeah, that's pretty everything I want to talk about the GUI. Any question about the machine learning model development pipeline? Something? What is the difference between CLAMP and CTEX? Yeah, that's a good question. So if you're familiar with CTEX, before CLAMP, we are trying to run CTEX as well. CTEX is a great tool, but at that time, it's very difficult to set up the CTEX environment. I think CTEX is much better now, the 4.0. So in some way, CLAMP and CTEX are similar. So we both use the CLAMP, the UEMA framework, if you're familiar with the development. And also we share the tab system. It means if you have some nodes run in CTEX, you can load that with CLAMP. And the difference is that the CLAMP is really designed as a development tool. You see, in clinical NLP, it's very common that you develop model on your own data set, but the model runs very good on your own data set. But when you switch to another data set, the performance drop a lot. It's a data-driven approach, right? In that case, you need to customize the model, change the dictionary, change the machine learning model, all these things. You can do that very easily in CLAMP, but in CTEX, you have to do a lot of programming, I believe. I think other difference, I guess CLAMP have more support on the machine learning corpus annotation part, machine learning model development. But in CTX, I don't think you can. I'm not sure. Can you annotate coppers? The time when I export test with CTX, we cannot annotate the coppers train machine learning model very easily. But in Clamp GUI, you can do that. It's like a development tool. I think that's probably a difference. And you can check the performance as well, right? Test with these standard coppers. We have lots of these clinical NLP tasks. You can compare the Clamp accuracy with the CTX accuracy as well, right? Right, thank you. So this Clamp GUI is our current version, and we are actively working on our Clamp 2.0. 2.0, in 2.0, I will introduce a lot of these deep learning stuff. The deep learning algorithm, including the cutting edge pre-trained refining algorithm, I will integrate them all into the Clamp. So probably we can make a release February or March something. Yeah, we are actively develop the deep learning based Clamp version.
Are there any other questions for Jinchi?
All right, any questions or do you have any issues with running Clamp? You can always give me an email. I have the how to get technical support from Clamp. You can give me email. My email is listed at the right. Technical support. Give me email. I will reply that. And
We also have a GitHub repository. Jinchi, can you just show them our...
yeah. So do we still have the link here?
Yeah, go down. Yeah, there you go. Discussion forum.
Right.
So
Yeah.
here you'll actually see some answers and workarounds for people who had issues
Have person ask question here, right? FAQ.
Yeah. And then if you have something that's not covered here, then you can, initiate an issue as well.
Yeah.
So I have a quick question to ask. I was wondering, I know Jinchi covered kind of fairly comprehensively, and we do have plans to actually cover specific topics in the future. But I was wondering if any of you have topics that you would like for us to cover in these CLAMP meetings, I mean the support office hours. You can, if you could send either me or Jinchi those or those topics, that would be great. We will make sure that we will get to those topics that you feel is important for you to get more clarification on.
Yeah, and if you have any suggestions or usability improvement suggestions, something like that, you can always give us an email.
Also, as you're using CLAMP, if you think about features which don't currently exist in CLAMP, but which you think would be useful for you in your specific work, you can, add that in, either send us an email or add that in to our GitHub repo, and we will see if we can address that in the next release.
Mm-hmm. Yeah. So in this demo, I'm probably focused on the interface side, but I guess in the future, I can prepare something like the programming API demo or something like that. Basically, you can use the CLAMP like a, Java library and then develop your own NLP functions and call the lower level CLAMP NLP API. Basically, every function I showed in the interface, we have API at the back end. You can develop based on the CLAMP NLP APIs if you're a Java developer.
Is there anything else that you would like to see us discuss? If not, I think, Jinchi, we are almost at the end of our time for the office hour.
Right. Okay. Thanks, and thanks everyone for interest in this CLAMP software. Give me a message if you need any help, technical help. Right.
All right. Thank you. Bye.
Thank you, everyone. Bye.